Hey everybody, Mr. Stewart here, and welcome back to Math. We've got this. In the previous video, we were looking at how, over here on the left, to take an algebraic expression where the powers are the same base, and we're multiplying, hence we applied the multiplication rule. So that's really what this series is about at this point in time, is how do we use those rules or laws to simplify these expressions. Now, thinking back to the last video, you noticed that we had these multipliers or coefficients for each of the powers. So as we ended that video, we were looking at how to simplify it. And essentially, we're looking for like factors for those multipliers so that we can reduce a pair of them, that is between the numerator and the denominator, reduce those like factors to 1 over 1. Now moving forward, what that means is here's what we have left. We have, again, grab the right pen tool here. So we have 2 copies of p to the 7th, and we have 1 copy of p to the power of 4. Now what I want you to recognize too, and this applies to the rule, I'm just going to come back to the top here. When you're multiplying fractions, I'm just going to break this up. So what you can do, and we want to do this every time, just until we get kind of comfortable with how things are organized, realize that we can split those products up into 2 fractions. Okay, because the rule when you multiply fractions together, and let me grab a highlighter here, is that you multiply top by top and the bottom terms together. So if you can do that, it would make sense that you can actually split them up into 2 of their own fractions. The reason why we want to do that is it certainly organizes things a lot better, but it shows us, let's grab the right writing tool here, it shows us that here we have 2, but the second fraction, recognize that it's a quotient. We can use the division rule. And again, let's highlight that. Let's make that clear, is that we have powers with the same base. So that's p to the 7th divided by p to the 4th. And don't forget here, we have a quotient we're dividing. So hence the reason for the subtraction, because that is what the quotient rule tells us that we are able to do. So we're left with 2 copies of p to the power of 3. And this is a whole lot nicer to express it this way, is let's just remove that symbol. That is that multiplication symbol, because we know that it is assumed, it is a convention, that multiplication happens between the 2 and the power. And there you go. Okay, so just a quick note here. What we're going to say here is this rule here. Again, that is your justification. That's your use of the quotient rule. Okay, now before we get timed out, and we certainly will, there's a guarantee of that. Let's have a look at this one. Okay, so looks a little strange, a whole lot different, but at the end of the day, once we work with it a little bit more, I think you'll see that it's really not. So notice this, right? Take the time to identify things. So we have a power here and a power here. They both have the same base, which is a. Then you have another grouping of powers. Here we have a b to the 3, b to the 4. They each have the same base. Now we're also, recognize, we're multiplying. So somehow, some way, that multiplication rule is most likely going to come back and be quite useful for us. Now we can go ahead and just do it, right? But I'd rather develop things so that they are a good line of reasoning. Let's just put it that way. So I'm going to try something here. Because we're multiplying, I know, perhaps you also know, you can use the dot notation here, you might also know that when you're multiplying a series of terms together, the order in which you multiply them together is irrelevant. So I'm just going to reorganize this. So let's put the A's together and the B's together. And we're running out of time. Look at that. 100% guarantee. All right, let's come back in the next video and we'll wrap things up.